In math, a regression function is a function that represents a series of data points on a graph. This function represents the closest possible way of connecting the points on a graph using one equation. Regression equations are often used in statistics and science to represent an ideal equation for an experiment's results. For example, if you drop a ball 10 times from different heights and record the time it takes to reach the bottom, using a regression function, you can find the time it takes for the ball to drop from any height. There are a few types of regressions. Linear, also known as a best fit line, is one line that represents the general trend. Quadratic is a best fit parabola or a binomial. Cubic is a best fit trinomial function with 3 degrees. Exponential regressions are equations of functions with x as the exponent. Logarithmic regressions are equations of functions with x as the variable in a log 10 function. Sinusoidal regressions are equations of functions with x as the variable in a sine function. We are going to plot the data points representing the world's population from 1930 until now. First, we create a new spreadsheet. In the cell labeled A, we are going to type year, because this is going to be our independent variable that we place on the x-axis. Now, in the cell labeled B, let's write population for our y-axis. Let's continue by filling out the table according to the data from the graph. If you are doing a science experiment, you can just put your results right into the table. Once complete, click in a cell that is not part of your data table. This will be used to store your regression equation. Now click Menu, Statistics, Stat Calculations, and select the type of regression that you wish to use. I'm going to choose quadratic regression. Click XList and select your X column. In our case, this is the year. Click Y-list and select your Y column. In our case, this is the population. When you are done, press OK. Now, we should see the equation of our regression as well as our R-squared value. The closer this value is to 1, the closer the equation is to the actual value. After we've entered our information, let's create our scatter chart of the points in the table. Press Menu, Insert, Page, and click Data and Statistics. Now click on the box on the left, which holds our y-axis. Now select your variable, which is in our case the population. Then do the same with the x-axis, and click Year. Our points should be plotted in the scatter chart on the screen. We can again find the regression by clicking Menu, Analyze, Regression, then select our regression that we wish to use. Our equation is displayed on the chart. Now let's see if a different regression would yield a better result. Click Ctrl-Z to undo and repeat the previous step. Notice the regressions look very similar, so it's hard to tell which one is more accurate. To find out, let's go back to our table and find our R-squared values. The quadratic regression from last time was 0.9978. I'm going to click Undo a few times to remove our regression. Now let's find our exponential regression. With an exponential regression, our R-squared value is 0.995, which is not as good as our quadratic. Now let's go back to the quadratic regression and see if the equation actually works. A quadratic regression is in the form ax squared plus bx plus c. So now I'm going to copy the a value and paste it into a calculator document. For our x value, let's choose the year 2015. That value needs to be squared. Then copy the b and c values and fill out the equation. When you're done, click enter, and you'll find that the value is very accurate.